Here are our learning objectives for today's topic. First, to define what a logarithm is and explain its relationship with exponent. Second, to identify and describe the different forms of logarithmic expression and their properties. And third, to apply the law of logarithm to solve and convert between exponential and logarithmic form. By the end of this lesson, we should have a better understanding of how logarithm work and how to use them in solving problems. What is logarithmic function?
Good day, everyone. Now let us first. Now what a logarithm is. The word logarithm came from the Greek words logos, which mean ratio or proportion, and aritmos, which mean number. Logarithm were invented independently by John Laffer, a Scottish mathematician who is also known as the father of logarithms. In simple terms, a logarithm tells you what exponent we need to raise a base number to get another number.
Now, let's move on the three forms of expression that involves logarithm. We have logarithmic function, logarithmic equation, and logarithmic inequality. So what is logarithmic function? It is a function is the inverse of an exponential function. The general form is this. F of x is equal to log base b of x, such that b is greater than 0, b is not equal to 1. Example is f of x is equal to log base 2 of x. But how about logarithmic equation? It is an equation involving logarithm variable. To solve it, you usually rewrite it in exponential form or use a logarithm properties. Example is log base 3 of x is equal to 2. So the last is logarithmic inequality. It is an inequality that involves logarithm expression. Example is log base 2 of x is greater than 3.
Answer the following if it's logarithmic function, logarithmic equation, logarithmic inequality, or neither. Number 1. F of x is equal to log base 5 of x. Number 2. Log base 4 of x is equal to 3. Number 3. 2 cubed is equal to 8. Number 4. Log base 2 of x is greater than 5.
Good day, students, and today I will explain the basic properties and laws of logarithm.
A logarithm is just another way of expressing exponents. It tells us what exponents we need to raise a base to in order to get a certain number. Now let's go through each property one by one. We have the first property, which means that the logarithm of b with the base of b is equal to 1. For example, logarithm of 3 with the base of 3 is equal to 1, and logarithm of 11 with the base of 11 is equal to 1. Because 3 raised to 1 is equal to 3, and 11 raised to 1 is equal to 11. In other words, we only need to raise b to the power of 1 to get b. Next, we have the second property, which means that the logarithm of 1 with the base of b is equal to 0. This means that a logarithm of 1 in any base is always 0. So we have here the example. We have the logarithm of 1 with the base of 3 is equal to 0, and logarithm of 1 with the base of 9 is equal to 0, because any number raised to the power of 0 is 1. So, what power of b gives 1? What do you think? Yes, you're right. The answer is 0. Now we have the third property, which means that the logarithm base b of x is equal to x. That shows that exponents and logarithms are inverse operations. They cancel each other out. We have here the example that the logarithm of 10 with the base of 5 is equal to 10, and the logarithm of 5 with the base of 2 is equal to 5. So when we raise the base to its own logarithm, the result is simply the x. Last but not the least, we have the fourth property. This shows that the logarithm base b of b to the power of x is equals x. We have here the example of the logarithm base 7 of 7 to the power of 2 is equal to 2, and the logarithm base 2 of 2 to the power of 2 is equal to 4. We are basically asking what power of 2 gives 2 raised to 4, and the answer is 4.
Now, let us discuss the logarithm of a number. Let a, b, and c be real numbers such that b is greater than 0 and b is not equals to 1. The logarithm of a number a with base b is written as log b equals a and defined as c equals to log base b of a if and only if b raised to the power of c equals a. This means that c is the exponent to which the base b must be raised to get a.
For example, if 2 raised to the power of 3 is equal to 8, then log base 2 of 8 is equal to 3 because 2 raised to the power of 3 is equal to 8. How? Kapag tinimes mo ng 3 beses yung 2, ang kakalabasan nun is 8. But notes, logarithmic function and exponential function are inverse of each other. This means that one operation can undo the other. Second, in logarithmic form, the base b and the argument a cannot be negative. However, the value of logarithm can be negative. For example, log base 10 of 0.01 is equal to negative 1 because 10 raised to negative 1 is 0.1. The formula is c is equal to log base b of a and b raised to c is equal to 8. Number 1. 10 cube is equal to 100. Since naka-exponential form siya, we need to convert it in logarithmic form. So, ang magiging base natin is 10. Ang magiging a natin is 100. And the last one is c. Ang magiging c is 2. Next is 2 cube is equal to 8. So, let's convert this into logarithmic form. So, ang magiging b natin is 2, ang magiging a natin is 8, at ang magiging c naman natin dito is 3.
Good day everyone! Now, let us know how to rewrite logarithmic form to exponential equation. A logarithmic form is written as logarithm whose base of b of a is equal to c.
And to change this into exponential equation, we simply arrange it as b raised to c is equal to a. So we have here an example. So the logarithmic form showing that the logarithm 2 of 8 is equal to 3. And when we change it into exponential equation, we have that 2 raised to 3 is equal to 8.
So in here, our b is 2 and c is equal to 8 and a is equal to 3. And when we change it to exponential equation, the answer is 2 raised to 3 is equal to 8. We have here another example. The logarithm 5 of 25 is equal to 2. And when we arrange it in exponential equation, we have the 5 raised to 2 is equal to 25. So we have here another example showing that the logarithm 4 of 1/6 is equal to 2. And when we change it into exponential equation, we have the 4 raised to negative 2 is equal to 1/6. So in logarithmic form, our b is 4 and c is 2 and a is equal to 1/6. And when we change it to exponential equation, we have the b is the 4 and c is equal to negative 2 and a is equal to 1/6. We just change the c and the a, which is the 1/6 and the 2.
Let's move on finding the value of each logarithms. Number 1, log base 3 of 9. Para hanapin natin yung value ng x, gagamitin natin ang exponential form. Kaya magiging 3 raised to x is equal to 9. Then iisip tayo ilang 3 ang i-multiply para maging 9. Dahil 3 times 3 is equal to 9, ibig sabihin 3 squared is equal to 9. Ang sagot ay log base 3 of 9 is equal to 2. Number 2, log base 6 of 260. Para hanapin ang value ni x, gagamitin natin ulit ang exponential form. Kaya magiging 6 raised to x is equal to 260. Mag-iisip tayo kung ilang 6 ang i-multiply para maging 260. Dahil 6 times 6 times 6 is equal to 216, ibig sabihin 6 raised to 3 is equal to 216. Kaya ang magiging sagot ay log base 6 of 216 is equal to 3.